The last thing we're going to study in this course for now is vectors. Vectors. In simple terms, a vector is a quantity that has both magnitude, size, and direction. Okay, it's customary to represent a vector by using an arrow. The length of the arrow represents the magnitude, and the arrowhead indicates the direction that we are going in. And so when we're looking at vectors, there are all kinds of quantities in physics that are represented by vectors. If you decide to fly an airplane, first thing you're going to do is go to ground school and learn how to do vectors, because flying a plane, a certain speed, direction, change in direction, and so we have magnitude and direction. So there's a couple of ways to represent vectors. First way is what we call the component form. We have to have a starting point and an ending point. Now a line goes forever. 2 points determine a line. You can't measure a line. Lines don't have measurement because they go on forever. A line segment is just the distance from one point to the next. That we can measure. A vector, though, has to have an initial point and a terminal point, so we have a direction. Now, the length is the same as the length of the line segment, but initial point to terminal point. So a vector, and in this book, they're going to use bold, lowercase letters. So a vector is equal to initial point, terminal point, point P, point Q, and you'll see the arrow above it, right? So vectors. Now with vectors, if the magnitude is 0, it's called the 0 vector, okay? No direction to it. It would just be a point, right? If we have two vectors that are equal, we write it like that. That means they have the same magnitude and they point in the same direction. So vector PQ and RS and TU are all equal vectors because their initial point P to Q, the magnitude, initial point R to S, the magnitude, the initial point T to U, the magnitudes are all the same, and they all point in the same direction. Another way of saying that is they're parallel. They're parallel, right? So vectors, we can add them, we can subtract them, we can multiply them, we can divide them, and we're going to look at it in a variety of ways. Geometrically, we're going to draw the arrows. So here's vector V, and where vector V starts, that becomes the initial point where vector V ends. Okay? The terminal point of vector V becomes the initial point of W, and VW, the initial starting point for V to the final stopping point of W, that vector is called the sum vector. It's called the sum vector. So when we want to add two vectors, the way we draw them is where one ends, the next one begins, and then from the initial point to the final stopping point, that is vector addition. That is vector addition. And it doesn't matter if I take vector V and then add vector W, or if I start vector W and then add vector V. Notice W, they're the same vector. V, same vector. The diagonal from the starting point to the end point, that diagonal is the sum of the vectors. And so vector addition is commutative. Vector addition is associative. If I take vector U and then add V plus W, or if I take U plus V and then add W, we end up at the same spot. So the zero vector, you'll notice that 0 is bold. That means it's a vector. It's not the number 0, it's the vector 0. And so V plus a vector 0 is just v. 0 is the identity. Here's two vectors. Notice they're the same size, but one's going that direction, the other one is going this direction. Initial point to terminal point. Initial point to terminal point. These two vectors are the opposites of each other. They're same size, opposite direction, which means if you add them, you get the 0 vector. Now, if you want to add or subtract vectors, the easiest way geometrically to do it is to have an initial point. And here's vector v, and there's vector w, and form the parallelogram. And from the